Hello, friends, and welcome to the Snoozy Scientist. I'm really glad you found your way here tonight. Wherever you are on this vast and beautiful planet, this peaceful corner was made just for you. A calm space where science and stillness can sit side by side, carrying you gently towards sleep. Tonight, we're going to drift forward into our distant future to witness the most haunting chapter in our sun's story, the day it dies. The sun feels eternal to us. For as long as humanity has looked upward, the sun has been constant. It has risen faithfully each morning, warmed our faces, guided our crops, and lit our skies. Entire civilizations have measured their time by its path. Entire religions have worshipped its glow. It has been our companion for billions of years, a guardian so steady that we came to believe it is eternal. But like every star, it is not immortal. It is already in its middle age, halfway through its lifespan, and when its end arrives, it will be unlike anything we can ever imagine. They say every good thing must come to an end. For a very long time, the earth has lived under a borrowed light. One day, that light will fade. The death of the sun is inevitable, and the process has already begun. But what will it look like when the sun dies? Will Earth survive long enough to see it? And could humanity, fragile as we are, endure beyond the death of our only star? Tonight, we'll step carefully into that distant future, moment by moment, to see the full story of how the sun will die and what it will leave behind. If you're already settling into this peaceful moment, it would mean the world if you gave this video a gentle like, maybe even subscribed if you'd like more sleepy science stories like this one. And if you'd be kind enough, let me know in the comments, where are you winding down from tonight and what time is it there? I love watching our bedtime map light up, one dreamer at a time. So now, take a slow breath, let your shoulders soften, and together, let's begin the story of what we will see when the sun is no more. The sun looks calm to us. When we step outside on a clear morning, it seems like nothing more than a golden disk, quietly hanging in the sky. Its light spills across oceans, forests, deserts, and cities, and to the human eye, it feels steady, eternal, unchanging. But this familiar face hides an extraordinary secret. Inside the sun, a furious storm rages every moment of every day, a storm that has been burning without pause for billions of years. At its core lies a furnace, hotter and denser than anything we can truly imagine. Temperatures climb to over 15 million degrees, and the pressure is so immense that atoms cannot resist. Here the sun's true work begins. Tiny particles, the nuclei of hydrogen, are forced together with such power that they fuse, becoming helium. In that instant, a small piece of their mass is lost and transformed into pure energy. It is this transformation, known as nuclear fusion, that makes the sun shine. Each second, the sun converts nearly 4 million tons of matter into radiant light and heat. That light rushes outward, taking thousands of years to travel from the core to the surface, and only 8 minutes more to cross the emptiness of space and touch the earth. To us, the sun appears perfectly stable, a constant companion in the sky, but stability is an illusion. Inside, the balance between gravity and energy is delicate, always shifting, always adjusting. Gravity pulls inward, trying to crush the star under its own immense weight, while fusion pushes outward, trying to tear it apart. In the quiet between these two forces, the sun finds its shape. This balance is not stillness, it is a dance, renewed every fraction of every second. If fusion slowed for even an instant, gravity would tighten its grip, compressing the core until fusion roared to life again. If fusion flared too hot, the sun would expand slightly, cooling its heart until the reaction settled down. What we see as calm is in truth a constant rhythm of tension and release, a heartbeat measured not in seconds, but in millions of years. The scale of this star is almost beyond comprehension. The sun is so vast that more than 1 million Earths could fit inside it. Imagine lining up globe after globe, every mountain and ocean and city multiplied over and over until they vanished into its fiery belly. Even then, the sun would have room to spare. Its mass makes up more than 99% of our entire solar system. Every planet, every moon, every drifting rock, even the icy comets that sweep through the dark, all are bound by its gravity. The sun is not just a star in our sky. It is the anchor, the master of the stage on which every story in this system unfolds. Yet for all its enormity, the sun is not a solid thing. It is made of plasma, a state of matter so hot that atoms break apart, leaving nuclei and electrons to flow freely like a restless sea. In this sea, storms erupt, magnetic fields twist and snap, and great loops of fire leap thousands of miles into space. These outbursts, which we call solar flares, remind us that the sun's surface is no calm surface at all, but a restless skin stretched thin over a raging heart. Even now, as you listen, solar winds stream from its edges, racing outward and brushing past our planet. Most days we barely notice, but sometimes these winds collide with Earth's magnetic field and set the skies alight with the shimmering curtains of the aurora. The sun speaks to us in whispers and in storms, even as it appears steady and still. When you gaze at the sun, you are not seeing it as it is in this moment. Light takes 8 minutes to reach us, which means we are always looking slightly back in time. The sun we see is a memory, a portrait from the recent past, traveling across the emptiness of space to arrive at our eyes. Think of it. Every warm ray that falls on your face began in a particle collision at the sun's core, a collision that happened long before humans walked the earth, making its slow journey outward before finally slipping into our skies. The sun is alive in ways that stretch our understanding of time. Its surface boils and churns, with vast cells of plasma rising and falling, like tides in a cosmic ocean. Sunspots bloom and fade, dark islands where magnetic fields knot themselves into snarls. These patterns shift across cycles that last years or decades, but when laid against the span of human history, they are barely moments. What we experience as a constant golden glow is the fragile balance of a star in motion, always adjusting, always changing, and as we begin to peer closer into its hidden life, it becomes clear that the calm we have always trusted is temporary. The sun is halfway through its story, and though it shines with quiet warmth today, deep inside, changes are already unfolding. What looks eternal is only passing through its middle chapters, carrying us all forward with it. Every star carries within it a hidden clock. It does not tick in a way that we can hear, nor does it mark time in minutes or years. Instead, its countdown is written into the very fabric of its birth, locked in place from the moment it first begins to shine. That silent timer is set not by chance, but by a single factor: mass. When the sun was born out of a cloud of gas and dust, its size determined everything about its future. Too little mass, and it would never have ignited at all, remaining a cold and dim body adrift in space. Too much, and it would have burned through its fuel in only a few million years before collapsing in a brilliant supernova. The sun formed with just enough mass to settle into a long, steady burn. That balance gave rise to a star that would shine for billions of years, nourishing worlds, stirring atmospheres, and giving life a chance to emerge. Yet it also sealed its fate from the very beginning. At its heart, the sun fuses hydrogen into helium, a process that releases the light and heat that streams outward to Earth. But hydrogen is not endless. Slowly, imperceptibly, it is being used up. Each second, hundreds of millions of tons vanish into fusion's fire, and though the sun holds vast reserves, the supply is finite. This is the mechanism of the clock. Once the fuel runs low, the star must change. The transition will not be smooth, and it will not be kind to the worlds that depend on it. Stars live their lives on a scale shaped by their mass. The most massive stars are like short-lived giants, burning with incredible brightness, but racing through their fuel in a brief, furious blaze. These are the stars that end their lives in colossal explosions, collapsing under their own gravity and unleashing a burst of energy so intense it can briefly outshine an entire galaxy. Their deaths scatter heavy elements into space, the gold in rings, the iron in blood, the calcium in bones. In their destruction, they seed the universe with the raw materials for life. Smaller stars like the sun are quieter storytellers. They burn for billions upon billions of years, stable and calm to our eyes, but their endings are more subdued. They cannot summon the fury of a supernova. When their fuel runs low, gravity still presses inward, squeezing the core tighter and hotter until new reactions begin to stir. The outer layers swell, the star expands into a giant, and for a short time it shines with a strange, swollen brilliance. But without enough mass to collapse and explode, the star eventually sheds its outer shell into space. What remains is a husk, a white dwarf, small and dense and glowing faintly in the dark. This difference between explosion and fading ember is written into every star before it even begins its life. Astronomers sometimes say that stars are born with their death already inside them. The sun's path is quiet compared to its larger cousins, but that quietness does not make it less dramatic. To the tiny creatures on Earth, a red giant looming across the sky will feel every bit as apocalyptic as the shattering roar of a supernova. It is only from the vantage of the universe that the sun's story seems gentle. The weight of the sun is both its strength and its weakness. Its mass gave us the long stability that made life possible, yet that same mass means the sun will never die in fire, only in silence. Its destiny was set in motion 4.5 billion years ago, long before oceans formed or continents rose. The timer has been ticking since then, each fusion reaction pushing the clock forward by a fraction of a second. From Earth, none of this feels real. The sun shines as it always has, steady and bright. But in truth, the internal countdown continues, unbroken and unstoppable, carrying our star toward a future already written in the laws of physics. And as the sun drifts further into its middle age, that silent ticking will bring changes that reach far beyond its core, changes that will one day be felt across the earth itself. The sun's countdown may stretch across billions of years, but its influence on Earth is not waiting quietly until the very end. Changes are already happening, slow enough that we cannot see them with the naked eye, yet relentless enough that they will one day decide the fate of our world. Every billion years, the sun grows about 10% brighter. To us today, this shift is invisible, too gradual to notice in a single lifetime, or even across the span of human history. But to the Earth itself, the increase is like a tightening grip, applying more and more heat with every passing age. The oceans are the first to feel this creeping pressure. They have been Earth's cradle for nearly all of its history, sheltering the earliest life and sustaining countless generations of creatures. Yet water, for all its resilience, cannot endure endless heat. As the sun brightens, the delicate balance that allows liquid oceans to exist begins to falter. The warmth stirs more evaporation, and clouds grow thick with heavy vapor. At first, this might feel like nothing more than a hotter climate, a world of denser storms and thicker humidity. But slowly, the cycle begins to spiral beyond control. Evaporation feeds itself. As oceans send more water into the air, The atmosphere grows rich with greenhouse gases, trapping even more of the sun's heat. The cycle quickens, and seas shrink under a sky that grows more hostile each year. What was once a planet of deep blue horizons will, in time, become a world of steam. The oceans will boil, not in sudden explosions of heat, but in an agonizing retreat, drop by drop, wave by wave, until the great basins lie empty and cracked beneath a choking sky. Long before the sun expands into a red giant, Earth's surface will already have been transformed. Rivers will vanish, forests will collapse into ash, deserts will sprawl across every continent, their sands scalded by an atmosphere heavy with water vapor and carbon dioxide. The once fertile soils will bake into lifeless crust. The air itself will become a suffocating blanket, trapping heat so effectively that the planet will resemble a second Venus, shrouded in burning. For life, the end will come quietly at first. Creatures will vanish from the seas as the water around them grows too hot to bear. Plants will struggle in air too thick and skies too dimmed by haze. Small pockets of survivors may cling to the last fragments of habitable land. But the pattern is inevitable. As temperatures climb, even the toughest organisms, those that endure extremes today, will be erased. Life loses this planet long before the sun loses its fire. It is a haunting thought because it means that Earth's timeline is shorter than the sun's. Humanity often looks to the distant death of the star as the end of the story, but the truth is that the world beneath our feet will become unlivable long before the sun reaches its grand finale. The planet does not need to be swallowed by the sun to perish, it will be undone by light itself. The image of a future Earth is one of silence. No waves lap its shores, for there are no seas left to stir. No birds call, no winds hum through trees, because the forests are gone and the skies are barren. The surface lies cracked and broken, every mountain and plain scorched under a relentless red glow. And above it all, the sun still burns, steady and strong, unaware that the world it once nurtured has already been lost. The earth will not need to wait for the swelling of a red giant to feel its death. The brightness alone, that steady rise of 10% each billion years, is enough to strip it bare. And as that invisible clock continues to tick, the warning signs will not come as sudden catastrophe, but as slow, inevitable unraveling. What we see as stability today is only a fragile balance, one already shifting toward a future where this planet is no longer home. The unraveling of Earth's habitability will not begin with silence or sudden catastrophe. It will begin with subtle shifts in the sky, small details that might at first feel like nothing more than a change in weather or season. These will be the first whispers of a transformation too vast for life to endure. As the sun continues to brighten with age, the quality of its light will change. To the human eye, it will appear sharper, harsher, and whiter than the soft golden glow we know today. On mornings when the sun rises, it will no longer carry the same warmth of color. Instead of a gentle yellow disk lifting above the horizon, it will blaze with a pale brilliance, almost dazzling, as if the sky itself had become more fragile under its intensity. Midday will no longer bring comforting radiance, but an unforgiving glare that bathes every surface in a hard, bleaching light. Shadows will tell part of the story. They will grow darker and more defined, not because the sun is closer, but because its brightness has become more piercing. A tree standing in a field will no longer cast a soft outline, but a sharp and almost unnatural silhouette, as though its shape had been burned into the ground. Buildings will appear edged with black, the light cutting with a clarity that feels foreign. The change may seem small at first, but it will be inescapable once it begins. The atmosphere, the protective veil that has shielded Earth for billions of years, will begin to betray its role. As the oceans send more vapor into the air, The sky will thicken into a suffocating greenhouse. Clouds that once carried rain will turn into heavy curtains of steam, trapping the sun's heat against the surface. Days will stretch hotter, not by degrees we can endure, but by leaps that strain every living thing. Nights, too, will lose their cooling relief. The heat will cling to the land, radiating back into an atmosphere already too swollen to release it. Imagine walking under such a sky. The air would feel heavy, pressing against the skin, hot with trapped energy. Breathing would no longer bring refreshment, but discomfort, as if every inhale were taken in a room filled with steam. Rivers would shrink, their waters evaporating before reaching the sea. Grass would wither to brittle straw. Even the wind would carry no relief, for every breeze would arrive warmed by the thickened atmosphere, like the air from a furnace. The earth will begin to resemble a mirror of its neighboring world, Venus, where heat once spiraled out of control and transformed the planet into a blistering wasteland. Thick clouds, heavy with vapor and carbon dioxide, will swirl endlessly, reflecting light but holding the heat beneath their blanket. The once blue skies will fade to a hazy pallor, veiled by layers of trapped gases. From the surface, the sun will still blaze white, but its light will struggle to pierce through the choking haze, leaving the world below in a strange twilight of heat and glare. The signs will be unavoidable for any who look up. Birds, if any survive to that time, would fly under skies that appear blinding at midday and dim at dusk. Plants would strain under the relentless glare, their leaves curling in the heavy air. Oceans, already shrinking, would seem to writhe as they reflect the hardening light. Humanity, if it still lingers on this warming earth, would look into the heavens and recognize that something permanent had shifted, something far larger than climate or season. The first warning signs will not arrive as violent explosions or sudden disasters, but as the quiet alteration of the most familiar sight of all, the sky above. The sun, which once felt constant and gentle, will become a harsher master. Its brilliance will carve sharper shadows, its whiteness will bleach the world below, and its heat will saturate the thickening air. Life will not need to wait for engulfing flames to sense its doom. The atmosphere itself will begin to close around the planet, transforming into a trap from which there is no escape. And while the Earth struggles under this intensifying sky, the inner planets will be moving along their own paths toward destruction, beginning with the smallest and closest of all. Long before the sun's swollen edge reaches the Earth, its first victim will already have fallen. Closest to the furnace, Mercury has always lived on the edge of survival. A barren rock without air or water, it has endured for billions of years in silence, circling the sun every 88 days, locked in a constant struggle between blistering heat and freezing darkness. But when the sun begins to swell into its red giant phase, Mercury will not endure for long. It will be the first planet to vanish. The process will not be sudden, like a stone thrown into fire, but gradual, drawn out over countless orbits. As the sun grows, it releases more light and more heat, but also something less visible, drag. The swollen star will expand, and its atmosphere will puff outward, reaching farther into the solar system. This extended atmosphere is thin, but not empty. Each time Mercury circles, it will brush against this ghostly veil, losing just enough momentum to fall slightly inward. The effect is slow, but it compounds with every orbit. Mercury's path will shrink tighter and tighter until escape is no longer possible. From a distance, Mercury's final journey would resemble a spiral. With each loop, it draws closer, falling into what astronomers call orbital decay. The planet that once raced so quickly around the sun will find itself locked in a death spiral, its fate sealed by friction with the star's expanded outer layers. The closer it moves, the stronger the pull becomes, until eventually Mercury can no longer resist. It will plunge into the sun, swallowed whole by the very star it had circled since birth. The end of Mercury will be silent to us, but unimaginably violent in scale. The surface will melt long before the planet reaches the sun's surface, its rocks vaporizing under the crushing heat. By the time it finally disappears into the fiery atmosphere, there will be no trace left, no remnant to mark where the innermost planet once spun. The smallest of the rocky worlds will be erased as if it had never existed at all. Mercury's death is more than just the loss of a planet. It is a warning, a preview of what lies ahead for the others. Watching its orbit collapse would be like watching the hand of a clock tick closer to midnight. Its spiral inward is the first domino in a chain that will one day reach Earth itself. For billions of years, Mercury has been a survivor, enduring extremes with nothing but stone and silence. Yet even that resilience has limits. Against the drag of an expanding star, even a planet cannot hold on forever. Imagining this from Earth gives a sense of scale that is both awe-inspiring and terrifying. To see Mercury, once a tiny bright point racing across the dawn or twilight sky, vanish into the sun would be to witness the beginning of the solar system's unraveling. The ancient rhythm of the planets, a clockwork that has marked time since the birth of the sun, would falter. The first note in a long, slow requiem would be struck. As the sun continues to grow, its reach will only extend farther, and Mercury's disappearance will set the stage for the next planet in line. Venus, shrouded in clouds and storms, will face its own inevitable destruction, torn apart as the star swells into its brightest and most dangerous form. After Mercury is erased from existence, the sun will not rest. Its glow will continue to intensify, its outer layers stretching farther and farther into the solar system. The next world in line is Venus, and though it has always been a planet of extremes, nothing in its long and violent history will compare to what awaits it when the sun expands into its red giant phase. Venus has often been called Earth's twin, similar in size and mass, yet so utterly different in character. Where Earth became a cradle for oceans and forests, Venus grew into a world of suffocating heat and storm. Its thick atmosphere of carbon dioxide and clouds laced with sulfuric acid makes it one of the most hostile places in the solar system. The surface pressure is strong enough to crush a submarine, and the heat is hot enough to melt lead. Even without the sun's swelling edge, Venus already burns in a greenhouse nightmare. But in the age of the red giant, even this furnace of a planet will collapse under a power far greater than its own. As the sun's radius grows, Venus will be caught in the path of destruction. Its skies, already a swirling cauldron of storms, will begin to tear apart under the onslaught of new heat. The winds, once capable of circling the planet in just a few days, will become wild and chaotic, ripped into patterns too violent for stability. Lightning will dance through clouds that are no longer clouds at all, but boiling curtains of gas ready to be torn away. The atmosphere will thin, not from calm release, but from violent stripping, peeled away layer by layer as the sun's outer envelope reaches for the planet. The surface will not endure long. The rocks, already at their breaking point under Venus's natural heat, will begin to liquefy. Lava plains that once hardened will melt again, seas not of water, but of molten stone. Mountains will buckle. Volcanoes, long dead or dormant, will be swallowed before they can ever erupt. The ground itself will blur into vapor, swept into the expanding star's embrace. In its final hours, Venus will not vanish quietly. It will be a spectacle of storms unraveling, of fire meeting fire, of a world collapsing into light. Imagine looking from afar as the planet, once a pale beacon in Earth's morning sky, is engulfed. It would not fade like a candle, but flare briefly in brightness, as its atmosphere and surface are absorbed, its very being consumed by the raging giant it orbited for so long. The destruction of Venus carries with it a chilling lesson. If a planet so hostile, so resistant to extremes, cannot withstand the swelling of its star, then no world within reach of that heat can hope to survive. Earth may lie slightly farther out, but the fate of its neighbor is a grim preview of its own. Venus shows us not only the scale of the sun's expansion, but also the truth that even entire worlds, planets that have endured billions of years of storms and fire, are fragile when the star they orbit decides to grow. The chain of loss moves outward, and after Venus is erased, the sun's light will fall upon the next world in line, the one we call home. The Earth, with all its oceans and mountains and histories, will face its own trial as the swollen sun rises across every horizon. After Venus vanishes into the swollen sun, the question lingers: what will happen to Earth? For centuries, scientists have debated whether our planet will be pulled into the sun's expanding body, or remain just beyond its reach, left circling as a blackened husk. The truth is that both fates are possible. Tiny shifts in the way the sun loses mass, or in the way Earth's orbit responds to those changes, could decide whether this world is swallowed whole or left to endure until it cracks apart in the heat. Either way, the ending is the same: Earth will not survive. The first sign will be the horizon itself. Instead of a golden sunrise, the sky will burn with a crimson glare that never fades. The sun will fill nearly half the heavens, so vast that day and night will lose their meaning. Shadows will stretch razor sharp across the land, etched in black against a glow so bright it will seem unreal. The air will shimmer constantly, a restless curtain of heat, bending the view of mountains, rivers, and plains. Continents will ignite like dry kindling. Forests, if any remain by then, will not burn in the way we imagine today, but will vanish in sheets of flame, consumed faster than winds can carry the smoke. Rock itself will begin to melt. Cities will not crumble slowly into ruins, for they will be erased in moments, their steel softened, their stones cracked apart by searing air. What humans built will be indistinguishable from the mountains and valleys that once framed it, all reduced to glowing fragments on a planet that can no longer bear life. The seas will fight their last battle in clouds of steam. Every drop of water that once covered the surface, from the deep blue oceans to the smallest hidden lakes, will lift skyward. Waves will crash one final time before the basins that held them begin to dry and fracture. As the atmosphere grows thick with vapor, it will trap even more heat, turning the ocean's farewell into the engine of their own destruction. Within a short span of geological time, Earth's waters, which had endured for billions of years, will be gone. The crust of the planet will buckle under the strain. Rivers of molten rock will spill across the land, glowing red against the deeper crimson of the sky. Volcanoes will flare, but their eruptions will be meaningless compared to the inferno that surrounds them. The very skin of the planet will become unstable, breaking open to reveal its fiery heart. The Earth itself will seem to shudder, as though it is aware of its own ending, and through it all, there will be no witnesses left. Humanity, long vanished by this stage, will not stand at the shore to watch the last tide roll back, nor gather in cities to see the final sunset. If we have not found another home among the stars, we will have been erased with all the rest, our memories scattered in traces of stone and dust. The Earth will die alone, silent beneath the gaze of the star that once gave it life. If the sun's expansion reaches far enough, the planet will finally be drawn into its outer edge. Earth will spiral inward, trembling as its orbit collapses until it is consumed. Within moments, the surface will dissolve into plasma, the rocks vaporizing in temperatures far beyond what any material can withstand. If instead, the planet manages to hold just beyond the sun's reach, its fate will be no less grim. It will circle as a lifeless cinder, its atmosphere stripped, its crust scorched until nothing remains but a dark and broken sphere, spinning silently in the void. The image of Earth's last days is both haunting and humbling, a horizon drenched in fire, continents glowing red, seas screaming into the sky as vapor, and a silence deeper than any we can imagine. It is the end of a world that carried every story, every heartbeat, every dream. Yet while Earth falls to silence, the sun's expansion will continue, stretching farther outward to touch the next world waiting in line. As Earth collapses under the weight of its fiery horizon, the sun's swollen body will turn its light farther outward, spilling into the realm of the red deserts that circle beyond. Mars, long thought of as Earth's barren twin, has waited in silence for billions of years. It has carried frozen scars of rivers that once flowed, dry beds of lakes that once shimmered, and whispering dunes shaped by winds beneath a thin, fragile sky. For all of human history, Mars has been a dead world, its air too thin, its cold too deep, its waters locked away as ice. But under the burning gaze of a red giant sun, Mars will awaken, though only for a fleeting moment. The first changes will be felt at the poles. For ages, Mars has stored vast sheets of frozen carbon dioxide and water, stacked in pale spirals across its caps. As the sun grows hotter and larger, its heat will begin to reach the Martian surface in a way it never has before. The ice will loosen and crack, releasing plumes of gas that thicken the air. The once razor-thin atmosphere will begin to gather weight, trapping more warmth close to the ground. The cycle will accelerate, melting more ice, feeding more vapor until the planet begins to change. Oceans that had been locked away beneath frozen ground may spill out across the plains. Valleys that once carried dry dust may rush again with liquid water, carving paths through the ancient surface. Shallow seas could spread where only deserts stretched before, and the reddish world might glimmer with reflections of liquid under the swollen sun. For the first time in billions of years, Mars would seem alive. Imagine standing in those moments on the rust-red soil, the horizon washed in the crimson light of a sun that now dwarfs the sky. The air would still be thin, the winds restless, but before you the surface would shimmer with water. It would be as if the planet had remembered what it once was, a fleeting resurrection under the touch of a dying star. The irony is as haunting as it is beautiful. As Earth is burned beyond recognition, Mars awakens, blossoming into a brief season of rivers and seas. Yet this reprieve is fragile. The sun that gives Mars this second chance is not a gentle guardian, but a predator already too large and too bright. The seas will not last. The same heat that melts the ice will soon boil the waters, turning them into vapor that rushes upward to thicken the skies. For a short while, the atmosphere will glow, dense with clouds and storms. Lightning may flash over lakes that had been frozen for eons, thunder rolling across valleys long silent. But the heat will not relent, and the same cycle that once doomed Earth will take hold of Mars. Vapor will trap more heat, and the planet will spiral into its own collapse. The haunting image is this: Mars, briefly alive, glistening under a red sky while Earth gasps in silence. The two planets, so often thought of as twins, will share their endings in different ways. One is lost in fire, the other reborn for a moment only to fall again. The seas that shimmer on Mars will be short-lived, leaving behind only steam and storms before they too vanish. The sun's reach will not end with Mars. Its swollen edge will cast its crimson light even farther out, toward the giants that wait beyond, their swirling atmospheres and icy moons preparing to face the glow of a star that has become both brilliant and deadly. As Mars shimmers briefly with seas that cannot last, the gaze of the swollen sun stretches farther outward, spilling its red light onto the realm of the giants. Jupiter, the largest planet in the solar system, has always been a world apart, a swirling titan of storms and clouds, so immense that it could swallow more than 1,000 Earths inside its bulk. For billions of years, it has kept its distance, far enough from the sun's warmth that its skies have remained frigid and its moons locked beneath ice. But in the age of the red giant, Jupiter will be transformed. The light reaching it will no longer be pale and weak as it is today. Instead, Jupiter will be bathed in a glow so intense it will paint its clouds in shades of crimson and copper. The white and amber bands that twist around its vast atmosphere will shift under this new light, glowing like liquid fire stretched across a planet larger than imagination. The Great Red Spot, that colossal storm that has raged for centuries, will churn under a sky that no longer looks blue or black, but bleeds with the reflection of a sun that fills much of the horizon, even at this great distance. This strange glow will not only touch Jupiter itself, but also the many moons that circle in its gravitational embrace. Worlds like Europa and Ganymede, which today lie locked in ice and shadow, will feel the warmth of the red giant's fire. For the first time, their frozen oceans may thaw. Beneath surfaces scarred by cracks and ridges, seas that have waited silently in the dark could break through to the surface, spreading into lakes and oceans under skies lit by Jupiter's reflected light. Europa's ice could split apart, releasing water in geysers that once froze instantly but now fall back as rain. Ganymede, the largest moon in the solar system, might reveal oceans vast enough to cover continents, hidden for ages beneath its frozen crust. For a fleeting moment in cosmic time, these moons could resemble places of wonder. Picture Europa under the glow of a swollen red sun, its icy plains softened into seas that mirror Jupiter's glowing bulk above. Picture Ganymede with shallow waters rolling across its surface, waves shimmering in the strange crimson light, its horizon crowned by Jupiter rising vast and beautiful in the sky. Even distant Callisto, with its battered ancient craters, might cradle lakes where once there was only ice. To imagine such a scene is to picture a second Eden, far from Earth, where water flows freely again and the air grows heavier with warmth. But this Eden is fragile. The same force that awakens these frozen moons will also undo them. The sun's heat will not pause at the perfect balance for life. It will climb higher, boiling seas that only just appeared, drowning skies in vapor that cannot hold their weight. Storms will rip across these newborn oceans, lightning flashing against red horizons. For a brief span, measured in thousands or perhaps millions of years, life could, in theory, have a chance to spark or thrive in these strange new worlds. But the clock will be merciless, and the window will close before such a chance can bloom into permanence. The beauty of Jupiter's transformation will carry a shadow of unease. A planet that has always been a distant guardian, shielding Earth from comets and asteroids with its gravity, will now be cloaked in blood-red light, glowing with the borrowed fire of a dying sun. Its moons, once silent and frozen, will sing for a moment with water and warmth, only to fall quiet again as the star that gives them their chance continues to expand. And as the sun's reach grows even farther, past the orbit of Jupiter and its glowing cord of moons, the next worlds in line, Saturn and the other giants, will also feel the touch of the red horizon. Their rings, their storms, and their frozen satellites will awaken in turn beneath the spreading fire of the dying star. As the red giant sun spills its fiery light across the solar system, the changes ripple outward beyond Jupiter itself. Its many moons, once frozen in silence, begin to stir in ways that seem almost miraculous. For billions of years they have hidden their secrets under crusts of ice and haze, but under the glow of the swollen sun, they begin to awaken. Titan, Saturn's largest moon, has always stood apart from the others. It is wrapped in a thick golden haze of nitrogen and methane, its surface hidden from view for most of human history. Today, it is a world where liquid does flow, but not water. Instead, lakes and seas of methane and ethane spread across its surface, so alien that they seem like reflections from another universe. In the light of the red giant, these seas will no longer remain locked in their strange cold state. The rising heat will melt Titan's frozen surface, transforming methane that once sloshed in lakes into surging stormy seas. The haze will thin and boil, revealing a sky unlike anything seen before. Imagine Titan under the swollen glow of the sun, its liquid methane seas shimmering like black mirrors, vast as oceans but unlike any found on Earth. The surface, which has remained frigid for so long, will become restless and alive with storms. Waves may rise higher than mountains, and lightning may crack across skies that glow orange and red under the reflection of Saturn's rings. For a short time, Titan will no longer be a frozen sphere at the edge of the system, but a liquid world of movement and energy. Farther in, another world responds in a different way. Europa, the small moon of Jupiter that has long fascinated scientists, will reveal its hidden heart. For ages, a crust of ice has locked away an ocean deeper than any found on Earth. Beneath its frozen shell, currents may already move, warmed by Jupiter's tidal pull, but under the heat of the dying sun, the ice will not hold. It will crack and splinter, breaking apart into shifting slabs. From the openings, plumes of water will burst into the thin sky, falling back as rain instead of freezing instantly as they do today. The hidden ocean will no longer be trapped in darkness. It will flood outward, spreading into seas that shimmer beneath the glow of Jupiter, looming vast above the horizon. It is here, on Europa, that one of the most haunting questions of all arises. If life already exists in those hidden waters today, simple and unseen by human eyes, then the red giant sun will give it a moment of freedom. Creatures that once drifted in eternal darkness could swim under open skies, their ocean world transformed into a surface sea. For a cosmic blink, Europa could host not just possibility, but life itself, alive and moving under alien stars. Yet this chance will not last. The same heat that frees the waters will boil them away. The ocean will collapse into vapor, clouds will thicken, storms will rage, and Europa's surface will dry into silence once more. Life, if it had a chance to rise, will vanish before it can take root. The pattern will echo across other icy moons. Ganymede, larger even than Mercury, could split apart to reveal seas vast enough to cover continents. Callisto, ancient and scarred, may briefly shimmer with lakes across its battered crust. Enceladus, with its plumes of ice today, could gush with fountains of water that do not freeze but fall back as rain. Each moon, for a fleeting span, will awaken into a world of seas and storms. To imagine these places alive, even for a moment, is to see a strange second act of creation, not in the cradle of Earth, but in the frozen outskirts of the solar system. Yet the story is already written. These oceans and seas will not endure. They will bloom like flowers in spring, brief and fragile, only to wither under the relentless gaze of the red giant sun. Life, if it stirs, will rise and fall in the space of a heartbeat, erased before it can ever be more than a whisper. As the moons awaken and then fade, the sun will not pause. Its fiery body will continue to swell, and its glow will stretch farther still, reaching the very skies of Earth itself, where the horizon will soon burn red, as day and night vanish into one endless blaze. As the sun swells to a size hundreds of times greater than the star we know today, its reach will spread across the heavens in a way that is almost impossible to imagine. The blue sky that humanity has known since the first dawn will vanish, replaced by a dome of fire that fills nearly every horizon. From Earth, if anything remains to see it, the sun will no longer appear as a distant circle, rising and setting, but as a vast red wall in the sky, stretching from one edge of the world to the other. Day and night, those ancient rhythms that once ruled every living thing, will disappear. There will be no dawn, no twilight, no gentle shifts of light. Instead, a permanent blaze will hang overhead, searing the planet with constant brightness. The familiar cycle that gave life its heartbeat, the rising and falling of the sun, will be erased. Time itself will feel broken, stretched into one endless day without relief. Shadows will no longer move across the land. They will be frozen in place, etched sharply against the ground, black and heavy under the unchanging light. Every inch of the sky will burn with crimson fire. Clouds, if any could still form under such heat, would not appear as soft white billows, but as ragged streaks of glowing vapor, lit blood red by the swollen sun. The air would shimmer with heat, bending the view of mountains and plains into restless mirages. From every direction, the sky would seem alive with motion, not from wind or weather, but from the roiling surface of the sun itself, so vast that solar storms and flares would appear to crawl visibly across its face. What once required telescopes to observe would now dominate the heavens with terrifying clarity. Imagine standing under such a sky. The horizon would no longer offer comfort, but a sense of suffocation, as though the heavens themselves were pressing downward. The sun's fiery edge would stretch far beyond the limits of vision, its surface glowing with rivers of plasma and eruptions of flame that arch higher than entire planets. The very scale of it would dwarf imagination. What had once been a gentle circle rising above the hills would have grown into a burning canopy, so overwhelming that it would feel as though the world itself had been dropped into the heart of a furnace. The colors of earth would warp under this light. Oceans, if any water somehow lingered, would no longer appear blue, but black and red, their waves boiling into clouds of steam that glow in the glare. Rocks would shine as if polished with fire, their surfaces reflecting the crimson sky. Even the air itself would seem tinted, thick with a rusty haze that chokes every breath. To look upward would not be to gaze into space, but to stare directly into the belly of the star that once stood far away, now close enough to erase all distinction between earth and sky. This endless day would bring not stillness, but chaos. Solar flares, great arcs of flame, would leap visibly across the sun's swollen body, each one large enough to swallow Earth many times over. These storms would send waves of energy rushing outward, battering what remains of the planet with radiation and heat. The sky would not be a backdrop, but a living, shifting inferno, writhing with storms of fire. For Earth, the sight of the red giant sun filling the sky would not be simply awe-inspiring, it would be annihilating. The world would feel as though it had been pulled inside the star itself, every horizon drowned in light, every shadow sharpened into blackness, every breath of air thick with heat. The sky that once offered shelter and wonder would instead press down like a tide of flame, turning the familiar face of the heavens into a vision of pure destruction. And while Earth writhes under its burning canopy, the sun will not yet be finished. Its light will continue to spread outward, and its fire will soon be felt deeper still, until even the crust of the planet begins to melt and the oceans themselves vanish into vapor and ash. When the sun has grown so vast that it fills the entire horizon, the surface of Earth will begin to change in ways that seem almost unthinkable. The boiling away of oceans, the collapse of forests, the death of every living thing will only be the beginning. Under the unrelenting heat of the red giant sun, the very crust of the planet will start to surrender. Rock, which feels so solid and permanent beneath our feet, will begin to soften, crack, and run like wax melting too close to a flame. The transformation will begin with the continents. Mountains, once towering symbols of permanence, will glow faintly at first, their peaks shimmering as if dusted with embers. Then, as the atmosphere grows ever hotter, the surface will start to break apart, spilling rivers of molten rock that pour across the land. The great basins left behind by the vanished seas will not remain as empty scars, but will fill again, this time not with water, but with glowing magma. The earth will be reshaped into a world of fire, its surface turned liquid under the crushing weight of the sun's blaze. Volcanoes, once fierce but limited eruptions of Earth's buried heat, will flare briefly but then lose their meaning. Their plumes will not rise into blue skies because there will be no skies left to hold them. The plumes will be torn apart instantly by solar winds far more powerful than any forces the Earth has ever endured. The glowing fountains of ash and lava will not drift gently across continents. They will be shredded into particles and swept away by the constant storm of radiation and plasma streaming from the swollen sun. The planet will become unrecognizable. Continents will vanish beneath seas of magma that stretch for thousands of miles, glowing like vast oceans of fire. Valleys and mountains alike will dissolve into the same molten plain, the differences between them erased in waves of heat. The crust, which once fractured into plates that drifted and clashed, will no longer hold together. Its fragments will be consumed into a single restless ocean of glowing stone. From above, Earth will not appear as the vibrant blue world that once cradled life, but as a sphere of searing red, its entire surface stripped bare, its details smoothed by fire. The process will be violent, yet eerily silent. With the oceans long gone, there will be no waves to crash, no winds to carry sound, no voices to cry out. The only motion will be the endless churn of molten rock, spilling, cooling, and reheating, while above it, the swollen sun dominates every inch of the horizon. Imagine looking down from space, if such a view were possible. The planet would glow like a coal pulled from a furnace, its skin shifting in shades of crimson, orange, and gold, licked by plumes of vapor and dust that spiral away into the sun's winds. The heat will not stop at the surface. As the outer layers of the planet dissolve, deeper regions will begin to stir. Minerals that once lay hidden beneath miles of solid crust will be exposed and vaporized in an instant. Elements that were stable for billions of years will be driven into new and violent reactions, feeding the glow of the molten seas. The Earth's magnetic field, born from the slow churn of metals in its core, will falter, leaving the planet naked under the fury of solar radiation. What remains of the atmosphere will be ripped away completely, scattered into space until the planet is nothing more than a glowing shell with no protection at all. The Earth will have become something both beautiful and horrifying, a world of fire. Its crust will ripple like the surface of an endless ocean, glowing brighter near the edges where the solar winds tear at it most fiercely. The planet will look less like the home that once carried life and more like the surface of a star itself, molten, burning, stripped to its barest form. But even this vision is not the final stage. The sun's expansion will not pause. Its swollen body will continue to breathe outward, and the winds that tear across the solar system will only grow stronger. What happens to Earth in this phase is only one step in the greater unraveling of the system, as the fury of the red giant continues to spread outward, touching worlds even farther away. As the Earth becomes a world of molten fire, stripped bare of seas and sky, the sun continues its transformation. No longer the calm, steady star of ancient days, it is now a red giant, swollen and unstable, pulsing with energy that it can no longer contain. With each breath, it begins to shed its outer layers, casting them off into space in waves of brilliance. These waves are not gentle releases of light, but torrents of plasma and radiation, storms so powerful they reshape the very structure of the solar system. These storms are the solar winds, and under a red giant, they grow into forces that dwarf anything the planets have ever endured. They are not breezes, not even gales, but rivers of charged particles rushing outward at hundreds of miles each second. They sweep across everything in their path, reaching worlds that once thought themselves safe in the outer dark. These winds carry with them the skin of the sun itself, the layers that once formed its glowing surface, now torn away and hurled into the void. For Earth, already a shell of molten rock, the solar winds are the final blow. What remains of the atmosphere, if any trace still clings above the magma, is ripped away in an instant. The winds strip it clean, scattering gases into space where they vanish forever. Without a shield of air, the molten crust is left naked, glowing fiercely as it is scoured by endless waves of particles. The solar winds do not stop with the air. They rake across the surface, tearing away fragments of dust, vaporized minerals, and ash, lifting them into the currents of plasma that race outward from the dying star. The ashes of Earth scatter into the void, not as silent drifting motes, but as part of a great river of matter that streams away from the sun. Particles that once belonged to mountains and rivers, to oceans and forests, to cities and monuments, are swept outward, joining the expanding shroud of material that surrounds the red giant. Every trace of what Earth once was becomes dust in the star's final storm. From a distance, this process would be hauntingly beautiful. The sun, vast and red, surrounded by a glowing halo of gas and dust, would appear like a lantern suspended in the dark. The material it sheds shines as it drifts away, lit by the brilliance of the core still burning within. Astronomers call this a planetary nebula, but to those who once lived under this star, it is the scattering of home itself. Earth is no longer a planet, but a memory carried in fragments across the void. The solar winds reach farther still, rushing past the orbit where Earth once circled, then beyond Mars, then Jupiter, carrying their destructive touch with them. Atmospheres that once clung to other worlds will also be stripped away. Moons that briefly stirred with water will be silenced as the winds peel back their protective shells, leaving them barren again. The giants of the outer system, even with their immense gravity, will not escape the thinning of their skies. One by one, the planets are erased not by fire, but by the relentless tide of the sun's own breath. Yet within this destruction lies the seed of creation. The gases and dust carried outward will not vanish into emptiness forever. They will spread, mixing with the material of the galaxy, adding to the clouds of hydrogen, helium, and heavier elements that drift between the stars. From that material, new suns will someday be born, and around them new planets may form. The ashes of Earth, scattered by the solar winds, could one day be part of another world, another story, another chance for life. But for now, in this chapter of the sun's life, the solar winds are extinction. They are the final erasure of a planet that once flourished with oceans and forests, a world that told stories and dreamed of the stars. The winds carry those stories into the dark, scattering them so thinly that no trace will ever be found. Earth will not end with a single collapse, but with its dust dissolved into the great breath of the dying star, drifting outward into silence. And as these winds continue to blow, scouring worlds and stripping skies, the reach of the sun will stretch still farther, until even the distant outer planets are forced to face the final light of their swollen parent star. As the solar winds roar outward, tearing away atmospheres and scattering dust into the void, Their reach does not stop at the inner planets or even at Jupiter and Saturn. Farther out, on the dim edge of the Sun's dominion, Uranus and Neptune await their turn. These distant ice giants, long shrouded in pale blues and shadowed storms, have always been quiet custodians of the outer solar system. For billions of years, they have circled on their wide orbits, faint and cold, barely touched by the warmth of the sun. But even here, where the star's light was once only a pale whisper, the age of the red giant will change everything. As the swollen sun swells brighter, Uranus and Neptune will glow strangely in the crimson light. Their atmospheres, which today are tinted in soft shades of cyan and cobalt, will shift under the fierce hue of the dying star. Instead of the cool colors that gave them their ghostly beauty, they will be painted in rusty tones, glowing faintly as though lit from within. The deep clouds of methane and hydrogen that swirl through their skies will catch the red glare, transforming these cold worlds into dim, eerie lanterns on the edge of a collapsing system. But this glow will not last. The same solar winds that stripped Earth to its ashes will eventually arrive here too, sweeping across the giants with unrelenting force. Uranus and Neptune are massive, but not massive enough to withstand the torrent of charged particles rushing outward. Layer by layer, their atmospheres will be peeled away, like smoke torn from a dying fire. Gases that had been bound by gravity for billions of years will escape into the solar wind, lost to the void. The bands and storms that once danced across their surfaces will fade, leaving them diminished, pale, and battered by the breath of their parent star. The moons of these giants will face their own fate. Neptune's Triton, with its frozen nitrogen geysers, and Uranus's collection of icy satellites will feel the sun's warmth briefly before being dragged back into silence. For a fleeting time, ice may crack and melt, releasing plumes into thin skies, but the moment will not endure. As the solar winds strip away what little atmospheres might form, the moons will be locked once again in their frozen shells. The short awakening of Titan Europa and Ganymede closer in will not be mirrored here. By the time the solar winds reach these distant companions, the chance for seas or storms will be gone. They will return to the silence of ice, circling planets that no longer hold their former majesty. From this far distance, the sun will still appear enormous, larger than it ever did in all of history, yet not as overwhelming as it was to Earth and Venus. The view of Uranus and Neptune, glowing faintly under a crimson sky, will be one of haunting quietness. These planets will not flare or erupt into dramatic destruction. Instead, they will wither under the steady stripping of their skies, fading away slowly until only pale remnants remain. They will not explode, they will not be swallowed whole, but they will be hollowed out, their beauty erased, their strength drained into the winds of their dying star. Imagine looking outward from one of Neptune's moons. The horizon would glow red, the faint blue giant looming above, its clouds dimming as they are pulled into space. The once mighty world would seem fragile, gas spilling into the void in great invisible tides, its form thinning like smoke dispersing in the air. In every direction, silence would dominate, broken only by the steady presence of the sun, vast and swollen, its light stretching even here to remind every distant body that the end had come. The outer planet's last stand is not one of triumph but of surrender. For all their distance, for all their size, they cannot resist the pull of a dying star shedding its layers into the universe. Their faint glow will be the last whisper of a solar system that once thrived with color and motion. Soon, even this will fade as the sun moves into its next stage, transforming its scattered layers into a spectacle of light that will mark the closing of its long and patient story. When the sun has swelled to its greatest size and its power has burned beyond control, it will begin to shed itself completely. Its outer layers, no longer bound by the star's failing gravity, will drift outward into space. These layers will not vanish into darkness. They will blossom into vast glowing shells of gas, forming one of the most hauntingly beautiful sights in the cosmos, a planetary nebula. The name is misleading. A planetary nebula has nothing to do with planets. Centuries ago, when astronomers first peered at these objects through small telescopes, they appeared as faint disks, like distant worlds, but what they truly are is the final, luminous breath of a star like our Sun. The layers it spent billions of years holding close will be cast away, expanding in every direction. Each shell of gas, lit by the light of the remaining core, will glow like a lantern suspended in the void. Colors will bloom across space. The gases will shine in shades determined by their elements: hydrogen glowing red, oxygen casting eerie greens and blues, nitrogen flaring in purples and violets. Together, these colors will spread across space in delicate patterns, like ripples on water, but vast enough to stretch for light years. Seen from afar, the sun's death will resemble a cosmic flower, petals of fire drifting outward, glowing softly against the dark. The patterns themselves will not be uniform. Some planetary nebulae expand into perfect circles, halos of light radiating outward in symmetry. Others form into complex shapes, like wings, hourglasses, or spirals, sculpted by magnetic fields and the motion of stellar winds. The sun's nebula will be no different. It will not release its final breath evenly. It will ripple, twist, and fracture into shapes too vast for the human mind to grasp. From Earth's perspective, if any observer were still here, the entire sky would blaze with ribbons of color, every horizon drenched in light from the gases once part of the sun itself. Seen from galaxies far away, our sun's death will be a small but brilliant jewel. Telescopes tuned to its glow would see the nebula shining for tens of thousands of years, a brief heartbeat in cosmic time, but breathtaking in its beauty. To distant civilizations, if any exist, the end of our star would not look like destruction. It would look like creation, a bloom of light where once there was only steady fire. This transformation is not only a spectacle of beauty, it is also a gift. The gases scattered outward will carry the elements forged in the heart of the sun: hydrogen, helium, carbon, nitrogen, and oxygen will all be cast into space, mixing with the clouds that drift between the stars. These elements are the building blocks of planets, oceans, and life. One day, perhaps billions of years in the future, they could gather again in a new nebula, forming another star, another system, and perhaps even another world with its own oceans and skies. But in this moment, during the birth of its planetary nebula, the sun will be at its most luminous and fragile. Its core, now exposed, will shine brilliantly on the gas around it, heating and illuminating the expanding shells. The nebula will glow like stained glass, suspended against the infinite dark. For tens of thousands of years, the sun will no longer look like a single star, but like an unfolding work of art, its light painting the cosmos in colors too vivid to forget. For all the destruction that came before, this is one of the most beautiful deaths in the universe. It is not a silent collapse like a white dwarf fading, nor a violent explosion like a supernova. Instead, it is a blossom, slow and graceful, casting its beauty across the galaxy before fading into memory. The sun's final act as a star will not be to consume, but to create something wondrous to behold. And when those shells have drifted far enough, when the glow begins to fade, what remains at the heart will be smaller than anyone could imagine, yet heavier than comprehension itself. The sun's ember, the remnant of all its long history, will shine faintly where once there was fire. As the planetary nebula blossoms outward, casting its delicate shells of color into the galaxy, the sun will be left with nothing more to give. Its outer layers, once the source of warmth and light for all life on Earth, will drift away into the void, leaving behind a bare core. What remains will be unlike anything the human mind can easily picture. The sun, once a golden giant dominating the sky, will shrink into an ember no larger than the earth. This remnant is called a white dwarf. To call it small would be misleading, because though its size contracts to match the width of our planet, its mass remains nearly the same as the star that once filled the horizon. Imagine compressing the weight of the sun into a body no bigger than Earth itself. The density defies comprehension. A single teaspoon of white dwarf matter would weigh several tons, more than an entire elephant. The fabric of atoms themselves is crushed together so tightly that the very structure of matter is altered, electrons packed against one another in ways they never would be under gentler conditions. On its surface, the white dwarf will glow with a pale light, not from ongoing fusion, because its furnace has gone out forever, but from the residual heat of what it once was. It will shine with a ghostly brilliance, like a coal that lingers in a hearth long after the flames have died. For billions upon billions of years, it will slowly cool, its glow fading so gradually that no living eye will ever witness its last flicker. In its silence, it carries the memory of the fire that once burned so fiercely. To imagine this change is to see a star's dignity stripped bare. The sun, which once rose each morning to light oceans and mountains, will be reduced to a faint pearl of light, adrift in the dark. From the distance of space, it would not dominate the sky as it once did. Instead, it would appear as a dim and lonely point, surrounded by the faint fading veil of the nebula it created. The brilliance that once gave birth to forests, rivers, and the heartbeat of life would be locked inside a body no bigger than the earth, yet so dense that no force could undo it. The white dwarf is not only a remnant, it is a warning of the passage of time itself. Our sun will never explode as a supernova. It lacks the mass required for such violence. Its destiny is this quieter ending, a slow fading, rather than a sudden collapse. But the quiet does not make it any less haunting. In that pale ember lies the story of everything that came before. The warmth that grew oceans, the light that carved landscapes, the fire that fed life's fragile spark, all of it condensed into one small ghostly star, glowing in the silence of space. Standing in the presence of such a remnant, if it were possible, would feel both humbling and unsettling. The surface of a white dwarf is unimaginably hot at first, millions of degrees, though it will cool over time. Yet despite its heat, its light will be faint, spreading outward into the emptiness without the power it once carried. The sun that once filled the entire sky will be no more than a glowing coal in the dark, fragile in appearance, yet impossibly heavy, as if the weight of history itself has been pressed into its core. It is in this stage that the solar system becomes a graveyard. The planets, their atmospheres gone, their surfaces scorched or frozen, will circle a light that no longer nourishes them. The Earth, if any remnant of it survives, will be nothing but a shattered husk or scattered dust orbiting the faint white star. The gas giants will still turn in the dark, but stripped of their beauty, reduced to pale shadows of themselves. And in the center, the white dwarf sun will keep its silent vigil, glowing like an ember from a fire long extinguished. Though haunting, there is beauty in this image. The nebula it left behind will drift through space, carrying the elements of life into the galaxy. The white dwarf at its heart will shine as a final reminder of the star that once burned so brightly. And though it no longer has the power to create, its presence marks the closing chapter of a story, billions of years in the making, a star that once gave birth to oceans and forests, and now lingers as a pearl of memory in the endless dark. And while the white dwarf glows faintly at the heart of a fading nebula, the rest of the solar system will fall silent, a collection of ghostly worlds circling a remnant star, their stories ended, their warmth gone, their music stilled. Around the pale ember of the white dwarf sun, the planets will continue to circle, but they will not be the same worlds they once were. The solar system, once a theater of color, warmth, and movement, will be reduced to a gallery of ghosts. Lifeless rocks and frozen ruins will drift in the faint glow, each orbit a reminder of what once had been. Where Earth once shimmered with oceans and forests, only silence remains. Its crust, stripped bare by fire and storms, will either have been swallowed into the sun's last convulsions or left behind as a husk of blackened stone. If fragments survive, they will circle the white dwarf as shattered relics, drifting in quiet arcs across the dark. No rivers will cut valleys, no clouds will carry rain. The cradle of life will be nothing more than dust, unrecognizable against the emptiness around it. Mars, which once teased humanity with the memory of water, will be locked forever in ice. Its brief awakening under the red giant sun will be erased, leaving nothing but frozen plains and the scars of ancient valleys. The dust that once danced across its deserts will lie still, frozen in place under a faint and fading light. Its horizon will never again see a sunrise or a sunset, for the sun it circles has no warmth left to give. Jupiter, the great protector, will linger as a pale ghost of its former self. Its swirling bands of storms will fade as the solar winds strip away its atmosphere, leaving behind a diminished shadow of the giant that once held more than 1,000 Earths within its volume. Its moons, which for a fleeting moment bloomed with oceans under the swollen red sun, will freeze again. Europa's seas will lock back into ice, deeper and harder than before. Ganymede and Callisto will be silent again, their waters lost beneath surfaces colder than stone. Even Titan, which once shimmered with seas of methane and for a short time stormy liquid waves, will be sealed in silence. Every whisper of motion will be gone. Neptune and Uranus, once painted in soft blues and greens, will fade into dim, colorless spheres. Their vast atmospheres will thin and vanish, peeled away into space until only their cores remain. Their beauty, always subtle and distant, will be erased completely. Their moons, too, will join the silence, circling in endless orbits without light or heat to stir them. In the distance, comets will still sweep across the dark, but their icy tails will no longer blaze. With no strong sun to heat them, they will drift invisibly, darkened fragments wandering through the remains of the solar system. The Kuiper Belt and Oort cloud, once fields of icy wanderers, will become a graveyard of frozen rubble circling endlessly, with no warmth to guide them. The silence of a dead system will be total. No winds will move, no storms will form, no tides will rise or fall. The orchestra of forces that once gave the solar system its rhythm will fall quiet, leaving only the faint hum of orbits carrying lifeless bodies around a star that has become nothing more than a pale ember. It is a haunting image to imagine the solar system not as the vibrant, dynamic place it once was, but as a still life frozen in time. The warmth gone, the music ended, planets reduced to statues of stone and ice, moons locked in eternal cold, and at the center, the white dwarf sun, glowing faintly like a coal slowly cooling in an infinite fireplace. To anyone watching from afar, our star's planetary nebula will eventually fade, and only the dim core will remain. To them, the solar system will look like a whisper of light, faint and unremarkable among the billions of stars. The story of Earth, of oceans and forests and life, will not be visible. It will have ended quietly, its echoes scattered into the galaxy as dust. Yet the orbits will continue. The dead planets, frozen moons, and lifeless rocks will keep circling in silence, tethered by the invisible pull of a star that no longer shines. The system will endure, not as a home, not as a cradle, but as a memory in motion, a ghostly ballet around a remnant sun. And beyond this haunting silence, the question arises of how such an ending will look to others who gaze across the galaxy, for to distant eyes, the sun's death will not appear tragic, but breathtaking. If there are eyes to see from far beyond our solar system, the death of the sun will not appear as devastation. It will not look like oceans boiling, crust melting, or planets stripped bare. From across the galaxy, all that destruction will be invisible. What other civilizations will see is beauty. To them, the end of our star will unfold like a cosmic firework, one more luminous bloom in a universe filled with the deaths of stars. From that distant vantage, our sun will no longer appear as a simple point of golden light. Instead, it will blossom. The planetary nebula created by its discarded layers will expand outward, glowing in colors that no single eye could ignore. Reds will shimmer from hydrogen gas, blues and greens from oxygen, purples from nitrogen, all glowing like stained glass in the vast cathedral of space. To an alien observer, our sun will not seem like a fading life, but like a newborn spectacle of light, spreading its last breath into a display of color and form. Seen through their instruments, or even their skies if they are close enough, the nebula will spread for light years, forming ripples and shapes sculpted by the sun's magnetic fields. It may appear as a circle of light, symmetrical and serene, or as a butterfly-like pattern with wings stretching outward. The form will depend on the sun's final moments, its winds and storms shaping the beauty of its departure. To any alien astronomers watching, our star's death will become an object of study, a glowing mark in their night skies, just as we today study the glowing remnants of other suns. For them, Earth's destruction will not be a tragedy. The boiling of seas, the collapse of continents, the silence of a dead system, all will be invisible from such a distance. Instead, the scattering of Earth's ashes into the solar wind will become part of the nebula's light. Every fragment that once belonged to mountains, forests, or rivers will shine faintly as it is lit by the core of the white dwarf at the center. To them, it will appear not as loss, but as radiance. The death of our home will look like beauty painted across the dark canvas of space. It is haunting to think of it this way. All the pain of endings, all the silence of extinction, all the collapse of worlds will vanish into distance. What remains visible across galaxies is only the art of the sun's passing. To alien eyes, it will resemble a celebration, a slow-motion firework that glows for tens of thousands of years before fading. They may marvel at its symmetry, note its colors, measure its expansion, and add it to their maps of the cosmos. Perhaps they will even name it, just as we name the nebula we see in our skies today. The Ring Nebula, the Cat's Eye Nebula, the Helix Nebula, each one is a dying star. Our sun's nebula will one day join their company, a jewel of light cataloged and admired from afar. Perhaps some alien world, circling its own star, will look upward as we once did. They will not know the stories of Earth, of oceans and trees, of creatures that once walked its surface. They will not hear the music of human voices, nor the whispers of wind through forests. They will see only the glowing remnant, a fragile lantern marking the end of a star. To them it will be a thing of beauty. To us it was everything. The death of the sun, seen from afar, will not be tragedy but spectacle, a bloom of gas and color stretching across the void, an echo of life written in light. And as the nebula expands, slowly dimming into the vastness, it will serve as a reminder that even in endings, the universe offers beauty. And while distant civilizations may admire this spectacle as one among countless others, closer to home, the passage of time will reveal the strange scale of such an ending. For though the nebula glows for only a brief moment in cosmic history, the white dwarf at its heart will linger for trillions of years, far longer than life itself could ever endure. When we think of death, we imagine an ending that arrives quickly, a star collapsing, a flame extinguished, a sudden silence. But the death of the sun is not so simple. Its final act stretches across scales of time so vast that human history itself becomes nothing more than a flicker. The timeline of its demise is not measured in years or centuries, but in billions and trillions, numbers so immense they can barely be grasped. The red giant phase, though catastrophic for the planets, is astonishingly brief in the life of a star. For billions of years, the sun has burned steadily, its light constant, its warmth unbroken. Yet when its hydrogen fuel begins to run low, it will change rapidly. In only a few 100 million years, an instant compared to its long history, it will swell to hundreds of times its present size. That expansion, violent and unstable, will be the most dramatic transformation the sun has ever endured. To us, 100 million years seems endless, longer than the rise and fall of every human civilization combined. But to the sun, it is a single heartbeat, the short finale of a story already billions of years old. The violence of the red giant stage will sweep away the inner planets, boil oceans, and turn Earth into magma, yet in cosmic terms, it will be over almost as soon as it begins. After casting off its outer layers and leaving behind a glowing nebula, the sun will shrink into its white dwarf core. And here the timescale changes again, from a quick and fiery convulsion to a near eternal silence. A white dwarf does not burn with fusion. It no longer creates new energy. Instead, it glows with the heat it has left, cooling ever so slowly over unimaginable spans of time. At first, it will shine brilliantly, its surface hot enough to rival the interiors of stars. But with no fuel, it will cool by fractions of a degree each century, its light fading across millennia. The timescale of this cooling stretches not into billions of years, but into trillions. Long after the nebula it created has faded, long after its planets have been reduced to frozen husks, the white dwarf will remain, glowing faintly in the dark, a stubborn ember that refuses to go out. To put this into perspective, consider humanity's place on this scale. Our species, Homo sapiens, has existed for roughly 300,000 years. All of recorded history, from the building of pyramids to the landing on the moon, fits into the past few thousand years. Compared to the lifespan of a white dwarf, our existence is not even a blink, not even the faintest spark. If the life of the sun were a great novel, humanity would appear as a single word on a single page, gone before the sentence has ended. Even the lifespan of our species, if it were to stretch for millions of years into the future, would still vanish against the scale of the white dwarf's endurance. For trillions of years, that ember will continue to glow, long after humans are forgotten, long after Earth has crumbled into dust. Civilizations, galaxies, even the very arrangement of stars will change around it, but the sun's remnant will linger, stubbornly present in the silence. The contrast is almost unbearable to imagine. The red giant phase, so violent, so apocalyptic for Earth, lasts only a short moment in cosmic terms. The white dwarf stage, silent and unchanging, stretches into timescales we cannot even picture. And humanity, with all its dreams, stories, and struggles, exists on a timescale so brief that it barely registers. The universe has patience far beyond our own, and in its patience, it shows us our fragility. From here, the story of the sun is no longer about flame and fire, but about silence and endurance. The ember at the center of the solar system will glow faintly, while its planets circle like shadows, a reminder that even when life is gone and warmth has ended, the story of a star does not finish quickly. It continues, not with noise or drama, but with the slow fading of light across trillions of years. And as we look to other stars, ones larger, brighter, and more violent than our own, we begin to see that the sun's quiet ending is only one version of a fate written across the cosmos. The fate of the sun may feel unimaginable, but it is not unknown. We know its ending because the universe has already shown us the script in the deaths of other stars. Every night, when we look up into the sky, we are surrounded by examples of the sun's future, scattered across the heavens like lanterns, telling their stories in light. Each dying star is a book, its pages written in gas, fire, and time, and by reading them, we glimpse not only what has happened to them, but what will one day happen to us. Among the brightest of these cosmic teachers is Betelgeuse, a red supergiant glowing in the constellation of Orion. To the naked eye, it shines with a reddish tint, a star so vast that if placed at the center of our solar system, it would reach past the orbit of Jupiter. Betelgeuse is living the very phase our sun will one day enter, though on a far grander scale. Its outer layers swell and pulse, expanding and contracting as if the star itself is breathing. Astronomers have watched it dim and brighten in recent years, a sign of the turbulence within, as fusion burns elements far heavier than hydrogen in its furnace. For Betelgeuse, the final act will not be a quiet fade like the sun's, but a supernova, a detonation so powerful it will outshine entire galaxies for weeks. By watching Betelgeuse, scientists can study what happens when a star grows unstable, when its balance tips and its outer layers spill outward. The sun will never become as massive or as violent, but the echoes of its future can be read in these red giants that scatter their brilliance across the sky. Each one is a living laboratory, a chance to see with our own eyes the processes that will one day reach us. Closer examples exist as well. White dwarfs, those faint embers left behind after stars like ours die, are scattered throughout the galaxy. Through telescopes, we can see them glowing faintly, each one the remnant of a star that once shone as brilliantly as our sun. Some are surrounded by planetary nebula, glowing shells of color that reveal how a star casts off its skin. Others linger in quiet darkness, having cooled for billions of years. By observing them, we confirm what physics predicts, that the sun's ending is not speculation, but certainty. Even the most beautiful nebula we admire in the night sky, the Ring Nebula, the Helix Nebula, the Cat's Eye, are not random patterns, but the final breaths of suns that once lived as steadily as ours. Their colors and shapes are pages in a book, each one describing how matter is shed, how energy flows, and how light fades. They are not only works of art scattered across the heavens, they are mirrors showing us the future of our own star. The awe comes not just from their beauty, but from their scale. When we look at a dying star, we are looking across millions of years of history, seeing light that left long before humans built cities or spoke words. In that light is the story of creation and destruction, written clearly for those who know how to read it. Astronomers are the readers, decoding the lines etched into spectra, measuring the rhythms of dimming and brightening, tracing the patterns of nebulas. Each observation is like turning a page in a book that the universe has already written, a book that includes our own final chapter. To think of stars this way is humbling. They are more than points of light scattered across the night. They are teachers, telling us that endings are inevitable, but also that endings create beginnings. Betelgeuse will one day explode, and from its ashes, new stars and planets will form. White dwarfs fade into silence, but the elements they scatter become the seeds of new life. Our sun, too, will follow the path, and when its time comes, its death will not only be destruction, but contribution, a scattering of elements into the galaxy for new worlds to inherit. When we look into the sky, we are not only admiring stars, we are reading. We are holding open the book of time, its chapters written in fire. Each red giant, each white dwarf, each glowing nebula is a sentence in that book. And as we study them, we come to realize that we are not separate from the story. We are living within it. The sun's fate is already written, and we are simply reading ahead to see the ending. And as we turn the page from these lessons written in distant light, we are brought back to our own sun, to the laws of mass and gravity that have shaped its destiny from the moment it was born. The lessons we learn from other stars show us something profound. Not every star shares the same fate. Some die in firestorms so violent that entire galaxies briefly bow to their light. Others collapse into silence, fading away like embers left in the ashes of a fire. The difference between these endings comes down to one thing: a force so simple yet so absolute that it shapes the destiny of every star: gravity. From the moment a star is born, its mass writes its story. The sun, like every star, is caught in a delicate tug of war between two forces. On one side, gravity pulls inward, trying to collapse the star under the weight of its own material. On the other, nuclear fusion pushes outward as hydrogen atoms fuse into helium and release energy that resists the inward pull. For billions of years, these two forces balance one another, creating the steady glow that nourishes planets and gives life a chance to exist. But when the fuel runs out, that balance tips and gravity decides how the story will end. For the sun, its mass is both a gift and a limit. With enough weight, gravity can crush the core of a dying star to the point where new and heavier elements begin to fuse, creating a chain of reactions that end in a colossal explosion, a supernova. These explosions forge iron in their cores, then collapse in an instant, unleashing energy so great it can outshine billions of stars. But the sun does not have that kind of weight. It is massive compared to Earth, more than 300,000 times heavier, yet in the company of stars it is modest. Its gravity is strong, but not strong enough to trigger the chain of collapses that lead to a supernova. Instead, when the sun reaches the end of its life, gravity will not drive it to explode outward, but to shrink inward. Its fuel exhausted, it will cast off its outer layers, leaving only its core behind. That core will not collapse into a neutron star or a black hole because it lacks the mass required. It will instead settle into the quiet, steady state of a white dwarf, dense beyond comprehension, but stable. Its death will not be a bang heard across galaxies, but a fade into silence, a glowing coal that endures for trillions of years. This destiny may seem less dramatic, but it carries its own awe. To imagine the sun becoming a white dwarf is to imagine matter pushed to its very limits. Atoms themselves are pressed so tightly together that their electrons resist further collapse, creating a new balance between gravity and pressure. The result is a star so dense that a single teaspoon of its material would weigh as much as a mountain, yet so small that it could fit inside the Earth. The quiet dignity of this ending is as extraordinary as the violence of a supernova, even if it does not blaze with the same spectacle. In this way, mass becomes the author of every star's story. The heaviest stars, with their overwhelming gravity, live fast and die violently, collapsing into black holes or scattering themselves across space in brilliant explosions. Smaller stars, like red dwarfs, burn so slowly they may outlast the universe itself, glowing faintly for trillions of years. The sun, caught between these extremes, is destined for a middle path. It will live long, steady, and patient, and in its death it will fade rather than erupt, leaving behind a remnant that glows quietly in the dark. When we look up at the stars, we are looking at fates already sealed. Each one has its own gravity, its own mass, its own destiny, written from the moment it was born. Some will blaze out in cosmic fireworks, others will dim into silence. The sun's story is not tragic, nor is it glorious. It is simply the path that its mass has written for it. And as the sun follows this path, the silence it leaves behind will not only erase planets, but also the traces of memory itself. For in time, even the marks of humanity, carved into stone and sent into orbit, will vanish into the same fate as everything else tied to this fading star. As the sun swells and the planets falter under its light, the question arises, what of the traces of humanity? For a species that has spent only a few 100,000 years upon this world, we have carved our presence into stone, steel, and sky. We have built cities that blaze with light at night, monuments meant to last for ages, and satellites that circle high above the earth like silent witnesses. Yet in the face of the sun's death, none of it will remain. The cities will be the first to vanish. Towers of glass and concrete, monuments of steel and stone, all will buckle under the rising heat. Streets will not crumble slowly as they do when civilizations fall, but will be erased in moments as asphalt boils, metals soften, and entire skylines collapse into glowing rivers of molten material. The monuments we imagined eternal, from the Great Wall to the pyramids to the carved faces of mountains, will not endure. They will dissolve into the same magma seas as everything else, their meaning lost before even their shapes are gone. Satellites, those mechanical eyes we placed in orbit to watch over our world, will not escape either. Already fragile in their thin shells of metal, they will be battered by solar winds long before the Earth's surface becomes fire. Their orbits will decay as the sun strips away the planet's atmosphere and alters its gravity. Some will burn against the thickening air, others will be cast outward, flung into the void as debris. None will remain as lasting monuments of humanity's reach. The plaques and records carried into space, from the golden record aboard Voyager to the messages etched into probes, may drift on for eons, but even these fragile tokens will eventually succumb to collisions, radiation, or the endless wear of time. The cradle of humanity itself, the Earth, will become unrecognizable. No trace of rivers or forests, no outline of continents, no hint of oceans will remain. The surface will be stripped clean by fire and solar winds until nothing is left but a sphere of molten rock glowing faintly before cooling into silence. Every book ever written, every song ever sung, every story told around a fire or recorded in a library will vanish without a trace. The memories we carried in stone, paper, and code will be erased along with the very ground they stood upon. It is a sobering thought. Even memory turns to dust. For all our striving to leave something behind, the universe is indifferent to permanence. Human history, so full of triumphs and tragedies, will not be carved into eternity. It will vanish with the planet that gave it birth, as if it had never been. Civilizations have always built monuments against time, pyramids, temples, skyscrapers, but even time itself bends to the will of stars, and the death of the sun will sweep all memory away. And yet there is a strange poetry in this erasure. The atoms that once made up our bodies, our monuments, our machines, will not be lost entirely. They will scatter into the nebula the sun creates, drifting outward into the galaxy. Though no form or meaning remains, the materials of our memory will continue, indistinguishable from the dust that seeds new stars. In that way, the fragments of Earth's story will not be written in monuments, but in matter itself. Imagine the Great Pyramid dissolving into dust, its stones carried into space as particles of carbon and oxygen, then falling into the clouds of a newborn star. Imagine the steel of bridges and towers scattered into the nebula, later bound into the crust of another planet, circling another sun. The forms vanish, the memory dies, but the matter lives on, recycled into new beginnings far beyond our own. The silence of this truth is heavy. Humanity, like every species before it, is a brief chapter in Earth's story, and Earth itself is only a page in the book of the sun. When the sun dies, even that page will be torn away, leaving only the faintest echoes written in dust. For all the beauty of our art, for all the reach of our science, for all the depth of our memory, in the end, it too will vanish. And yet, as the sun erases even the last traces of what Earth once was, the story of life does not end there. Beyond the ashes, beyond the dust, the cycle of stars continues, and the matter of lost worlds becomes the seed of new ones. When we imagine the death of the sun and the erasure of Earth's memory, one question lingers like a whisper in the dark. Could humanity escape? Could we, fragile as we are, step beyond the fate of our home star and find shelter somewhere else? It is a question that blends science with longing, physics with hope. For while the sun's death is inevitable, humanity's end is not necessarily bound to it. Our species has always been restless. For tens of thousands of years, we wandered from continent to continent, crossing rivers and oceans, never content to remain in one place for long. That same restlessness carried us into the skies, into orbit, and onto the moon, and one day it may carry us even farther, into the wider galaxy. If any species is to dream of escaping the death of its own star, it is one like ours, endlessly curious, endlessly hungry for more. The first step would likely be colonies on nearby worlds. Mars, though hostile and barren today, has always captured our imagination as a possible second home. With enough technology, future civilizations could build domes or even terraform regions of its surface, warming it, thickening its atmosphere, and filling its valleys with rivers once again. For a time, Mars might serve as a refuge, a place to carry humanity's story forward after Earth is no longer habitable. Yet even Mars cannot escape the sun's eventual expansion. Its brief reprieve under the red giant's glow will end in the same silence as Earth's, and humanity would need to look farther still. Beyond Mars, the moons of the outer planets offer another possibility. Europa, Ganymede, and Titan all hold reservoirs of water and complex chemistry. In the far future, long before the sun swells to consume them, civilizations might learn to hollow out these icy worlds, building oceans and cities beneath protective shells. Such places could serve as stepping stones for expansion into the wider solar system. But the sun's death will not spare them either. In time, every world tied to this star will suffer the same fate. If humanity is to endure, it must learn not only to move within its own system, but to leave it altogether. This is where the idea of generation ships arises, vessels so vast they carry entire societies within them. These ships would not travel quickly compared to the speed of light. Journeys between stars might take thousands of years, lifetimes stacked upon lifetimes. But if each generation cared for the ship, passed on its purpose, and kept moving forward, such voyages could succeed. Entire civilizations could drift between stars, carrying fragments of Earth's story across the galaxy. It is an idea both haunting and hopeful that the descendants of humanity could be born, live, and die among the stars, never touching a planet, yet carrying with them the memory of oceans, forests, and skies. Interstellar travel, though distant in our grasp today, remains the most profound hope. If one day humanity could leap between the stars, reaching worlds that circle suns far younger and brighter than our own, we could build futures unbound by the death of this system. Technology we can only imagine now, engines driven by fusion or even antimatter, sails pushed by light itself, could make such journeys possible. Perhaps humanity's greatest achievement would not be what it built on Earth, but the decision to leave Earth behind and scatter among the stars. The sobering truth remains that time is both our enemy and our ally. The sun's death lies billions of years ahead, which means there is time to prepare, time to grow, and time to imagine futures that reach beyond our cradle. But that time is not infinite. If humanity does not look outward, if it does not take its restlessness into the stars, then its story will end here, scattered into the same dust as every other species that has walked the earth. And yet, even against inevitability, there is hope. For if a species born of dust and oceans could one day teach itself to light fires, build cities, and step onto another world, then perhaps that same species could learn to escape its dying star. The thought itself carries both awe and longing that the fragile spark of life lit on Earth might endure, not only for millions of years, but for billions, carried forward into places where new suns rise. As we turn from this possibility, the question remains of whether such a legacy, even if achieved, would outlast the silence of time. For even if humanity escapes its home star, what it leaves behind will not endure. The cradle itself will vanish, and with it, the memory of our beginnings. When we imagine humanity's future under a dying sun, the question of escape feels natural. Colonies, generation ships, distant stars, all possibilities for survival. But there is another idea, one far stranger and more audacious. Instead of leaving Earth behind, could we move it? Could we take the very cradle of humanity, this fragile blue world, and shift it to safety? At first, the thought sounds like myth, as if it belongs in a story told around a fire rather than in the realm of physics. Yet scientists have asked it seriously because the mathematics of the sun's brightening and expansion leaves little choice. In about 1 billion years, long before the red giant phase, the sun will have grown hot enough to boil the oceans and strip away life. If humanity wished to preserve Earth as a living planet, it would need to slowly nudge it outward, keeping pace with the sun's changing brightness, moving the orbit farther and farther into the cold until it rests at a distance where oceans can still flow and skies can still breathe. The proposals for how to do this are as wild as they are fascinating. One suggestion is to use asteroid flybys, carefully steering massive rocks through space so they pass close to Earth and transfer momentum. With enough precision, these repeated nudges could gradually push Earth into a wider orbit, like tapping a spinning top again and again until it shifts its path. Each flyby would need to be timed with impossible accuracy because the difference between a life-saving nudge and a catastrophic impact is razor thin. Over millions of years, thousands of these carefully choreographed encounters could, in theory, carry Earth outward towards safer distances. Another proposal imagines using enormous solar sails, structures larger than continents, deployed in orbit around Earth. These sails would catch the constant stream of photons from the sun and use their momentum to gently tug on the planet. The pull would be tiny, far too weak to notice in a day, a year, or even a century. But across millions of years, the sails could slowly draw Earth away from its peril, carrying it outward like a ship guided across a cosmic sea. Perhaps the most ambitious idea is to build planetary engines, machines anchored to Earth itself, designed to push against the vast weight of the planet and adjust its orbit. These engines might harness the energy of fusion or even the very mass of Earth's core, channeling immense power into slow but steady thrust. Imagine colossal towers rising from the surface, each one capable of shifting the trajectory of the planet by the smallest of margins. Over billions of years, those margins could add up, carrying Earth to safety. The scale of these projects is almost beyond imagination. To move a planet is to contend with forces so immense that even describing them in numbers feels abstract. The energy required would be far greater than all the power humanity has ever produced. The precision would need to surpass anything we have ever engineered. And the time scale, stretching across billions of years, raises questions about whether any civilization could endure long enough to see it through. It is a contest between engineering and time. Could any species maintain focus across spans longer than its own recorded history by factors of millions? Could humanity, or whatever it becomes, devote itself not to centuries or millennia of progress, but to billions of years of continuous effort? The question is not only whether we could move Earth, but whether we should even try. There is something deeply emotional in this thought. Earth has been our only home. Its rivers carved our stories. Its skies held our dreams. Its soil nourished every generation that came before us. To imagine abandoning it feels like betrayal, and yet to imagine dragging it across the cosmos with machines and sails feels like something equally audacious, an act of devotion almost beyond comprehension. Would saving Earth mean preserving its memory, or would the act itself erase what it was? The sun will not wait. Its brightening is already underway, slow but unstoppable. If humanity does nothing, Earth will be lost. If it dares to try, Earth could in theory be carried outward, perhaps finding a new equilibrium under a fainter sun. Yet even if that were achieved, the red giant stage will still come, and the solar winds will still strip the system bare. Moving Earth might delay the inevitable, but it cannot erase it. And so the question becomes not just whether we could move Earth, but whether we should. Do we devote ourselves to saving the cradle, or do we accept that every cradle is temporary, and that our survival lies not in holding on to one world, but in learning to build new ones? As this question lingers, the thought of what humanity leaves behind becomes heavier. For even if we scatter among the stars, or move our planet itself, what of our legacy? What of the fragments of ourselves we send drifting into the void? Even if Earth itself cannot endure, even if the sun erases the cradle of humanity, not everything tied to our existence will vanish with it. For as fragile as we have already sent fragments of ourselves into the wider cosmos. Our legacy, scattered across the void, is not only written in stone or soil, but in the machines and messages we have placed among the stars. These may become the last whispers of humanity, drifting far beyond the ruins of Earth. Some of these fragments are our spacecraft, small and silent, but stubborn in their journeys. The Voyager probes, launched in the late 20th century, are now billions of miles from home, sailing into interstellar space. Each carries a golden record, etched with music, greetings, and images meant to tell the story of Earth to whoever might one day find it. The sounds of rain, of birdsong, of human laughter are inscribed there, waiting in the dark. Long after the last forests vanish, those voices will still exist, carried in silence aboard ships smaller than a bus. They are not alone. Pioneer 10 and 11 drift outward too, each bearing plaques engraved with maps and drawings. New Horizons, which once raced past Pluto, continues its path deeper into the Kuiper Belt. These tiny messengers have already left the glow of the sun behind, their signals fading as they travel, yet their bodies remain. With no atmosphere to corrode them, no gravity to pull them back, they could drift for billions of years, long after Earth has turned to magma and cooled to dust. There are also the signals, invisible but countless, that humanity has already sent. Radio and television broadcasts, pings from radar, messages deliberately aimed at the stars, all spread outward at the speed of light. They form an ever-expanding bubble around Earth, carrying fragments of our history into the galaxy. The first news broadcasts, the earliest songs sent through the air, even the static of human communication, all of it races outward, growing fainter but still present. A civilization thousands of light years away could, in theory, catch these signals and listen to echoes of Earth's story long after our world itself is gone. Beyond the probes and signals, there are other artifacts that may endure. Metal sculptures on the moon, rovers left on Mars, discarded stages of rockets circling the planets. These small traces of engineering may survive in some form, shielded by distance from the sun's fury, though eventually solar winds and cosmic collisions will scatter them too. For a time, they stand as reminders that life on Earth reached outward, even briefly, into space. It is a haunting thought to imagine what might happen billions of years from now if another intelligence were to stumble upon these relics. An alien civilization might find the golden records aboard Voyager and puzzle over the etched diagrams of DNA and pulsar maps. They might hear the recorded laughter of humanity and wonder about the creatures who once lived under a warm sun. They might find only fragments, corroded by time, half erased, leaving them to guess at the meaning behind our symbols. To them, Earth may be nothing more than a faint nebula in their skies, long gone, its memory surviving only in scraps of metal and whispers of radio waves. Yet even in such faintness, there is something profound. Humanity's legacy will not only be the things we built, but the attempt itself. The act of sending messages, of carving plaques, of recording voices to cast into the dark, is itself a declaration that we existed and that we cared about being remembered. Whether or not anyone finds them, these probes and signals mean that humanity, in its brief flicker of time, reached out to the universe and said we were here. And even as these relics drift onward, silent and patient, the vast scale of time will continue to dwarf them. For while they may endure for billions of years, the white dwarf remnant of the sun will glow for trillions, far longer than even our messages can survive. Against such scales, humanity's legacy becomes fragile, scattered like dust upon the wind. But dust itself is not meaningless, just as stars that died long ago gave us the elements in our blood and bones, so too might the matter of Earth and the relics we scatter become part of something new. A probe may drift until it collides with another world, its fragments mixing into alien soil. Atoms from our satellites may one day help form the body of a new star. The legacy of humanity may not survive in stories or monuments, but in matter itself, recycled endlessly in the great engine of the universe. And as these possibilities expand in thought, the sheer weight of time presses closer. For if our legacy is so fragile, so brief, then what does it mean against a universe that stretches beyond comprehension? To understand that, we must begin to grasp not only the scale of space, but the emotional scale of time itself. When we speak of the sun's life, the words themselves stretch into numbers, so immense they almost lose meaning. Billions of years, trillions of years, epochs upon epochs of time. For a human mind, which measures life in decades, centuries at most, such spans feel impossible to hold. To understand them, even faintly, we must compress them, fold them down into scales that fit into the smallness of our own lives. Only then can we begin to glimpse the awe of what is at stake and the fragility of the life that unfolds within it. If the entire history of the sun, from its birth in a cloud of gas to its death as a white dwarf, were squeezed into a single year, then all of human history would take place in less than the final second of December 31st. The pyramids, the rise and fall of empires, the voyages across oceans, the landing on the moon, all of it would blink by in less than the space of a breath. Even the entire existence of our species, Homo sapiens, would be so brief it would hardly register. We are flickers of light within a story that stretches endlessly before and after us, and yet in that flicker, we experience time with a weight and intimacy no star ever could. A single day to us feels full of meaning, a year can carry joy or sorrow that seems endless, and a lifetime becomes a story worth telling. This is the emotional scale of time. For the universe, a billion years may pass without event. For us, a single moment can feel eternal. The contrast is staggering. Consider the span of the sun's remaining life. In about 1 billion years, its brightening will strip the oceans from Earth. To the cosmos, this is tomorrow. To humanity, it is beyond comprehension. We cannot imagine building anything that lasts even 1 million years, let alone 1 billion. Then there are the trillions of years the sun will endure as a white dwarf, glowing faintly in silence. 1 trillion years is 1,000 billion, numbers stacked upon numbers until the mind begins to fail. For comparison, the entire age of the universe itself, from the Big Bang until today, is less than 14 billion years. The white dwarf sun will outlast that span many times over. It will endure so long that galaxies will change their shapes, stars will die and be born anew, and yet it will still remain, cooling quietly, a stubborn ember in the dark. And against that vastness, our fragility becomes clear. Human lives are counted in tens of thousands of days. Civilizations may endure for thousands of years, but eventually they crumble. Species may survive for millions, but extinction comes for all. Even the mightiest mountains rise and fall within a few 100 million years. Nothing we know is built to match the scale of stars. We live in a universe of giants, while we are fragile sparks appearing for a moment, then vanishing. Yet there is wonder in this fragility, for though our time is short, we are capable of seeing the long story. We can trace the lives of stars across billions of years. We can understand, at least in part, how the sun's fate is written by its mass, how galaxies rise and collapse, how the elements in our blood were forged in ancient explosions. The fact that beings with lifespans so small can glimpse the vastness of cosmic time is itself a miracle. It is as if sparks from a fire could look up and understand the lifetime of the forest around them. Compressing these numbers into something we can feel makes them even more astonishing. Imagine if the age of the universe, nearly 14 billion years, were a single day. On that scale, humans would have existed for only the final fraction of a second. All of recorded history would be the faintest whisper of breath. And yet in that whisper, we built cities, sent probes into space, asked questions about the stars, and told stories about our place within them. This is the awe of the emotional scale of time, to realize that we are both nothing and everything at once. Nothing because the universe would continue without us, indifferent to our brief flicker. Everything because in our short time we have given meaning to the vastness, we have learned to see it and to marvel at it. The stars may last for trillions of years, but they will never tell their own stories. Only we can do that. And as we sit within this fragile spark of existence, knowing how small we are compared to the span of the sun, we are drawn to reflect on the greater cycle of life and death written across the universe. For the death of our star is not only an ending, but also a beginning in the endless rebirth of stars and worlds. When we think of the sun's death, it feels final. Oceans gone, continents erased, Earth turned to silence. Yet in the wider universe, endings are never only endings. Every star, even one as modest as our sun, becomes part of a larger cycle, one that turns death into creation. What seems like a conclusion to us is on the scale of the cosmos only a handoff, a scattering of ingredients that will one day give rise to something new. When the sun sheds its outer layers and blossoms into a planetary nebula, it will not be discarding those gases into nothingness. Those clouds of hydrogen, helium, carbon, oxygen, and nitrogen will expand outward, carried on solar winds into the fabric of the galaxy. For a time they will glow with colors lit by the white dwarf at the center, but as centuries pass, the glow will fade, leaving only drifting clouds of enriched material. These clouds will mingle with others, mixing with the remnants of countless stars that lived and died before. Over millions of years, gravity will begin its quiet work again. Dust and gas will gather, drawn together into denser clumps. Each clump will attract more, growing heavier, until one day it collapses under its own weight. From such collapses, new stars are born. Around those newborn stars, the leftover gas and dust will spin into disks, flattening into rings that eventually clump into planets, moons, and asteroids. The cycle begins again. It is not only hydrogen and helium that flow from dying stars, but the heavier elements too, forged in stellar furnaces. The carbon in our bodies, the oxygen in our lungs, the iron in our blood, all were created inside stars that died long before the sun was born. Those stars exploded or faded, scattering their elements into space, and the sun formed from that enriched debris. Our planet, our oceans, and even life itself exist only because earlier stars gave their lives to create the materials that could one day make us possible. In this way, every human being carries the memory of ancient stars in their very bodies. The sun will join that cycle, contributing its own ashes to the galactic sea. Though it will not explode as a supernova, its planetary nebula will still scatter enough carbon and oxygen to enrich the interstellar medium. Billions of years from now, the dust of the sun may become part of another star, or swirl into the crust of a planet circling a distant sun. Perhaps life itself will one day emerge on such a world, nourished by the atoms of our own long vanished star. The matter that once warmed Earth's forests and oceans may find itself woven into alien rivers or alien lungs. In this way, death in the universe is never truly an end. It is a transformation. The cycle of stars ensures that the cosmos is always renewing itself. Stars are born, they live, they die, and from their remains new stars rise. Galaxies shimmer with this constant exchange, their arms filled with nurseries of light where gas clouds collapse and ignite. The very stars we admire in the night sky are part of this process, some newly formed, some nearing their end, all part of the rhythm of creation and destruction that has been playing since the first stars lit up the universe. The awe of this truth is overwhelming. We fear endings because they seem absolute. But in the universe, endings are beginnings written in another language. The sun's death, for all its devastation to Earth, is also a gift. It is the passing forward of material, the scattering of seeds that will one day bloom again. The cycle does not erase what came before, but transforms it, building new worlds on the foundation of the old. And so when the sun finally fades into its white dwarf state, when its nebula dissolves into the galaxy, its legacy will not only be the silence it leaves behind, but the stars and worlds it will help to create. Death becomes creation, and the story of the universe continues without pause. As we let that image settle of suns dying to give birth to new ones, we are drawn to one last question. What will we, standing under the sun today, truly see when it reaches its end? What final spectacle will the earth and its ghosts witness before the light is gone forever? For all the science, the timelines, and the numbers, the question remains, what will it actually look like? If Earth or something upon it could endure long enough to witness the final act of the sun, what sight would unfold before those eyes? What would the death of our star look like? Not in theory, but in the sky itself. The first thing would be the horizon, no longer golden at dawn or fading into deep blues at night, but permanently red. As the sun swells into its giant phase, the color of its light will shift, its glow bleeding crimson across every landscape. Every sunrise and sunset will merge into one endless twilight. Shadows will grow sharp and distorted, stretching long and thin across the ground as the sun becomes both larger and harsher. The delicate balance of day and night will vanish, replaced by a constant blood-red glare. The world will feel caught inside an eternal evening, beautiful and terrifying at once. Then the oceans will begin to boil. What once shimmered blue beneath the skies will turn to clouds of steam. Great plumes of vapor will rise upward, thickening the atmosphere into a suffocating blanket. Rivers will dry into canyons, lakes will vanish into empty bowls, and rain will never fall again. The sound of waves against the shore, a song that played for billions of years, will be silenced forever. From space, Earth will no longer be a blue world, but a pale and clouded orb, shrouded in white steam as its seas vanish into the sky. As the oceans die, the continents themselves will ignite. The crust will glow as though alive, fissures splitting across mountains and plains, pouring magma into valleys where forests once grew. Volcanic plumes will rise but be swallowed instantly by the sun's fierce winds, swept away into the void. Cities, monuments, every trace of humanity's hand will be consumed, not in slow decay but in fire. Earth will not crumble piece by piece. It will melt, its very skin reduced to rivers of flame. Above, the sky will burn with fire. The sun will dominate it, filling it so completely that no stars will be visible, no night to relieve the endless brightness. The sky will be a canvas of red and orange, flares arcing outward from the sun in waves thousands of times larger than Earth. Solar storms will whip across space, peeling away atmospheres, scattering the remains of worlds into dust. To stand beneath such a sky would be to see not only light but movement, a living storm of fire painted across the heavens. And when the sun finally sheds its skin, the spectacle will grow even more surreal. The gases cast off will drift outward, forming a nebula glowing in colors far beyond the range of any sunset. From Earth's remains, if any observer could still look upward, the sky would be filled with veils of blue, green, and violet light, patterns sculpted by the dying breath of the star. The nebula would not be fleeting. For tens of thousands of years, the sky would glow with this farewell, a cosmic lantern shining against the dark. It would be the most breathtaking show in the history of Earth. No eruption, no storm, no disaster in its long history would rival it. A horizon that bleeds red forever. Oceans turned to steam, land ignited into rivers of fire, a sky filled not with clouds but with flames, and veils of color stretching light years across space. It would be a sight so beautiful that it surpasses imagination, yet so final that it marks the end of everything we have ever known. And when the nebula fades, when the last glowing veil dissolves into the galaxy, all that will remain is the white dwarf at its center, a faint ember shining with memory. For those who could witness it, the death of the sun would not be destruction alone, but a spectacle so awe-inspiring it could only be called a farewell written in light. As the vision of this cosmic theater lingers, it carries us to the final reflection, for in witnessing the end of our star, we are reminded of the fragility of life, the inevitability of endings, and the beauty that can still shine even in the silence of death. The journey of the sun is not only the journey of a star, it is also our story, because everything we are has been written in its light. For more than 4 billion years, the sun has risen and fallen over oceans and forests, over mountains and plains, over the fragile lives of creatures that have come and gone. Its warmth gave Earth its rivers, its winds, its seasons. Its steady fire allowed life to take hold, to grow, and eventually to ask the very questions we have asked tonight. What will happen when the sun dies? What will become of us? It is a strange truth to hold in our hearts, the same light that cradled us, that has guided migrations, nourished crops, and inspired poets, will one day erase us. The skies will turn red, the seas will boil, and the continents will ignite. Every trace of human memory, every monument, and every word will be scattered into silence. And yet, even in this ending, the sun will not fall into nothingness. In its death, it will scatter its gases into the galaxy, enriching it with the very elements that make life possible. Its final act will not be destruction alone, but creation, It will light the universe anew, helping to seed new stars, new planets, and perhaps even new lives we cannot imagine. This is the paradox of existence written in the stars. The things we love are fleeting, yet the matter they are made of endures. The warmth of the sun will not last, but the atoms of its body will continue, folded into the fabric of the cosmos. Our earth will vanish, but its dust may one day be part of a mountain on another world, or the breath of another living creature. Endings are never only endings, they are beginnings in disguise, written across scales of time so vast they leave us trembling with awe. To sit under the sun today, to feel its light on our faces, is to sit in the presence of both life and death. Its rays that warm your skin are the same rays that remind us of the inevitability of change. We are small compared to the life of a star, yet we are also extraordinary, because in our brief flicker of time, we have learned to see the vastness. We have learned to read the stories of dying stars in the sky and to recognize in them our own future. No other creature on earth has done this. No stone, no river, no mountain has wondered about its fate. Only we have asked, and in asking, we have become part of the story in a way no silence can erase. So tonight, as we let these thoughts settle gently, let us reflect on what it means to live under borrowed light, to wake each day knowing the sun will rise, but also knowing it will not rise forever, to love more fiercely because time is fragile, to marvel at the skies not only as they are, but as they will one day become, a canvas of red horizons, oceans of fire, and a nebula glowing like a farewell lantern to the universe. If you've drifted here with me, through oceans boiling, through planets dying, through the rebirth of stars, then perhaps you too feel that mix of dread and wonder, that haunting beauty of a universe where nothing lasts, yet everything continues. The same light that warms us will one day erase us, but in its death, it will light the universe anew. And if you want to keep exploring these mysteries with me, if you'd like to wander further into the strange and the beautiful, then I'd be grateful if you gave this video a gentle like, maybe even subscribed, so that next time we can drift together into another of the universe's haunting stories. And if you'd be kind enough, let me know in the comments, where are you listening from tonight, and what time is it there? I love watching our bedtime map light up, one dreamer at a time. So now take one more slow breath. Let your eyes grow heavy. Let the vastness of time and the quiet of the stars cradle you as you drift into rest. And together, let us wait under the light of a sun that still burns, knowing it has stories yet to tell before it finally says goodbye.